Alright, so here's my last video on adding and subtracting fractions by finding a least common denominator. So this one's got a bunch of stuff going on with it, so make sure hopefully if you watch one of them, you watch this one. But hopefully you watch the other ones first so you have some of the basics down. Alright, so a few things I want to do first, some kind of like notation things, I suppose. I had said in one of my videos I don't like subtracting, so anytime I see a subtraction problem, right away I change it to addition. Just make sure that every sign in the numerator after that changes signs. I'm going to change this into a plus, but then it becomes positive 2x plus 1. Change your signs in the numerator only and make sure you change all the signs, okay? At this point, one other thing I want to do too is maybe group up the numerator in parentheses. So x plus 2 cannot be factored, so I'm going to group that up because that's going to be important in a moment, you'll see. And maybe right here, group this together too, that can't be factored either. So 2x plus 1, maybe group that up. Alright, so I'm going to go ahead and start to now build my least common denominator. Before I can do that though, I need to factor. I'm going to try to build your LCD before you factor anything. Both of my denominators can be factored this time. The first fraction has a greatest common factor. I can pull out a 2. So I'm left with 2 times x minus 1 once I factor that. If you need help with factoring, go back and watch some of my videos from earlier in the year. The second one's a trinomial. Two numbers that multiply to 3 but add up to negative 4 would be negative 3 and negative 1. So now everything's factored and now I'm able to build my LCD. The only coefficient I have is 2. And so that'll have to be part of this ideal bicycle, this perfect denominator. And then every variable chunk that I see as well. So both of them have an x minus 1, so I'll need that piece. I don't need both of them, just the higher of the two if there's higher powers. If they're equal, I just need to take that first power. I also see an x minus 3 piece, so I'll need that as well. So those are the 3 pieces that I need every denominator to have. This is sort of that perfect bicycle. That's the analogy that I like to use. So every denominator needs to become that denominator. So let's take a look at what I have and see what's missing. So the first fraction, if you like to do a checklist, it has a 2, so check that off, I don't need that. It has the x minus 1 piece, so I don't need that one either, but it needs x minus 3. And so I'm going to multiply the bottom by x minus 3 and the top. And notice what's going to have to happen, and this is why I wanted to use parentheses at the beginning, is when I multiply these together, I'll need to make sure that I distribute everything using FOIL or using the box method, making sure everything gets distributed and multiplied together. Alright, let me switch colors and let's take a look at that second fraction. Again, if I use my checklist, comparing the denominator I have to the LCD that I want it to be. It has the x minus 3 piece, check. It's got the x minus 1 piece, check. But it doesn't have the 2, so I'll need to multiply the bottom and the top of this by 2. Okay, let's go ahead and see what happens when I do all this now. So I'm going to make one big fraction line, because these two fractions now will have the same denominator. I'll go ahead and write that down. So it's 2, then times x minus 1 times x minus 3. The order doesn't matter, and please don't multiply those together. Just leave those separate. In the numerator, though, I will want to do some multiplication. And so let's multiply this together. X minus 3 times x plus 2. Hopefully, many of you are at the point where you can do this in your head. If not, you can do FOIL or do the box method. I'm going to just do it in my head real quick. It ends up being x squared minus x, and then minus 6, okay? And for that second part, then let's do that in green. I have to distribute that 2. Now, the reason that I had changed that plus sign at the very beginning was I didn't want to have to worry about distributing negatives, and I've already taken care of that. So just distributing this 2 now into the parentheses, I'm going to have a positive 2x, or I'm sorry, a positive 4x, and then a positive 2 once I distribute. Okay, let's go ahead and make this look a little bit neater by simplifying, combining some like terms. So I've got, let's see, x squared plus 3x, and then minus 4. Okay, and then once again I'll include my denominator of 2 times x minus 1 times x minus 3. Now at this point, this is where we had always stopped in the previous videos. However, watch what interesting thing happens this time. I've been saying we always try to refactor that numerator because if you can, sometimes things can be canceled out, and if you can cancel things out, you have to cancel them out. This time, for the first time, we have something that actually can be factored. Two numbers that multiply to negative 4 and add up to 3 are a positive 4 and a negative 1. So I can factor this into x plus 4, x minus 1. And if you take a look now, I have common factors. That x minus 1 in the top can cancel out with the x minus 1 in the bottom. if you can do something like that, you have to do something like that, and the only way to tell is to factor. And so in this case, my final simplified answer becomes x plus 4, I can drop the parentheses, over 2 times x minus 3. It's a lot of work just to add two fractions together, but that's what we need to do.